The last section of Chapter 3 is on investment and mixture problems. And so you do need to know the formula for interest is I equals PR. A lot of times you'll see I equals PRT, where the T equals the time. Most of the time in the problems that I'm going to give you, the time is just 1 year. So they're going to want to know how much after 1 year. So if you're multiplying by 1, that doesn't change the value. So that's why in this case, we're just going to use interest equals principal times the rate. All right, so let's just get started on it. Here we go. Once again, we're going to use tables to put down the information we know, and then use our formula, that I equals PR, to put those together into an equation that we can just solve, because we know how to solve equations. All right, so Marvin invests $12,000 in 2 different plans. Plan number 1 has an annual percentage rate of 6%, and plan number 2 has an annual percentage rate of 9%. The total interest after 1 year is $828. We want to know how much did he put into each plan. So together he put in the $12,000. How much is in plan 1 and how much is in plan 2? All right, so the 2 things we have here are plan number 1 and plan number 2. So let's set up our table. Plan 1 and plan number 2. All right, 2 plans, and so in these 2 plans, the interest is going to equal the rate times the principal times the rate. So we know the rate, so we can say principal times the rate is what we want, and we know the rate for number 1 is 6%, and now remember, we don't want to deal with percentages, so we're going to change them to decimals when we're working with them. If we need them to be percentages at the end, we can change them back, but we're not. We want money. So we're going to change the rate to 0.06 for plan number 1 and 0.09 for plan number 2. So we've got our rate. We just need to know the principal. Well, that's the problem. That's what we want to find out. So remember from several sections before where we said what we're going to do is we're simply going to choose one of our parts to be the variable, and then talk about the other one in relation to the variable that we've chosen. So let's just say, and I want to make sure that I'm doing the same one. There we go. We're going to do, let's just say that this larger one, we're just going to call X. All right. So if this larger one is X, remember we've done this type of thing before. If the larger one is X and together he put in 12,000. So that means that plan number 1 is going to start out with the 12,000, but you're going to take off however much was in plan 2. So plan number 1 is going to be 12,000 minus X. Let me talk that through again. So the $12,000 was what was in both. If we take the 12,000 and then take off however much we put into plan number 2, that's what's going to be left for plan number 1. All right, so now the principal times the rate is going to equal our interest. The principal times this rate is going to equal our interest. So when we get interest over here, if we add those 2 interests together, we should get 828. Because we don't know what those are, we can just add these parts that we're going to multiply together. So the plan number 1 is 12,000 minus X, all times 0.06. And then we're going to add to that the interest for plan number 2. The interest for plan number 2 is going to be these 2 multiplied together. And if it helps, put in your chart, your interest is going to be the principal times the rate. So this 0.06 times 12,000 minus X. And this one is 0.09X, which is what we have here, 0.09X. So these 2 added together are going to equal what did we say? 828? We did. 828. All right. So now, and I have it written differently up there because it's easier if we have the monomial out front, because now we can multiply through. And when we do that, since I did it already, I'm going to use what when we multiply through, it's 720. So take the 12,000 times 0.06, and you should get 720. minus 0.06x plus 0.09x equals 828. Combine like terms. 0.09 minus, now be careful, this negative has to go along with this 0.06. This is negative, so we're going to have 720. The 0.09 is larger, so it's going to be positive. 0.03x equals 828. Subtract 720 from both sides. 0.03x is going to equal 108. Divide by 0.03, and x is going to equal, let's see, what is that? 108 divided by 0.03, 2 zeros, 3 times 3 is 9, 6, 3,600. Okay, so once again, we got a solution. Now we've got to put it back into what is it that they're asking. How much did he invest in each plan? So in plan number 2, he invested 3,600. So then to get plan number 1, you're going to take the 12,000 that he invested in both. So you'll take 12,000 and subtract off this 3,600 that he invested in plan number 2. Is that a 9? 8. Ha. So the plan number 1, he invested 8,400. You can also list them instead of saying plan 1 and plan 2. You can say the 6% and the 9%. But these, make sure that you have it labeled money, and labeled which plan it goes with. All right? Okay. Easy sneezy, we're halfway there. All right. Because we said we were going to do investment problems and mixture problems. So investment problems are simply interest equals principal times rate. So set yourself up a chart to show principal times rate equals the investment equals the interest. Not investment. So principal times rate equals the interest. And then you can determine, am I going to add those, or am I going to, or is something going to be equal? You can set up your equation that way. The other type of problem we're going to do is mixture problems. A lot of these have to do with scientific type mixtures. Sometimes you'll have mixtures of different kinds of nuts and the costs of those. But what we're going to do right now is a scientific, if we're doing a scientific project, we're doing some labs. Andy has 75 milliliters of a 5% sulfuric acid solution. How much of a 20% solution should be added to create a solution that is 15% sulfuric acid? So once again, if you can set up a table to show what you know so that you can find out what you don't know, that's going to be the easiest. So what we've got is, we've got 2 different types of solution. So we're going to just call it the 5% and the 20%. All right, so number 1 and number 2, or however you want to do that. So the 5% solution and the 20% solution. And so we're going to have the amount of the solution times the percent. So we're going to set up, if we've got the 5% solution obviously is 5%, the 20% solution is obviously 20%. If we've got 75 milliliters of the 5%, that's how much of it we have. We're going to add how much of the 20% solution. So that's what we don't know. We're going to add X. And so we want a solution that is 15% of whatever we have. So what we want to end up with is, we want to end up with 15% solution. How much are we going to have of that? Well, that's going to be the 75 plus X. Because what we're doing is we're taking 75 milliliters of this 5%, and we're taking this many milliliters milliliters of 20%. We're mixing it together into a larger beaker. And so this larger beaker is going to have this amount plus this amount. All right. So this amount plus this amount should equal this amount, right? So let's set up an equation that looks like that. So 0.05, 5%, 0.05 times 75 milliliters plus 0.2x, because I moved my decimal 2 places over, and that should equal 0.15 times 75 plus x. And there's your equation that looks scary, but once again, you've done these already. So this part should be the easy part. So put it on pause, do it on your own, and come back to me. And I'm going to use my chart that I already multiplied on. All right, here we go. Did you do it already? I hope you did. I hope you got the right answer. Here we go. Multiplying these two through, you should get 3.75 plus your 0.2x equals 11.25 is the 0.15 times 75 plus 0.15x. Now it's a simple matter of getting the like terms together. So the x's, let's move the x's over to this side. So minus 0.15x. So we've got 0.05x on this side. And now we're going to subtract 3.75. So 0.05x should equal, what does that equal? 2, 3, 4, 5, 5, 10 minus 7. 7.5. Divide both sides by 0.05. Oh, 1.5 is 5. 150. So x equals 150. So what does that tell us? 150 is x. X is up here. This is the amount of the 20% solution. Let's see what they asked. How much of a 20% solution should be added to create a solution that is 15% sulfuric acid? So we need to add 150 milliliters of the 20% solution. And that is our final answer. Whew. So the hardest part is going to be just setting up your equation. Once you get an equation, it just goes back to just solving. And that's hopefully what you're getting good at, because we've done a lot of just plain solving equations. So set it up. Set up your table so that you can see what part goes with what. And so with the mixture problems, you're going to have to add a smaller and a larger percentage together to get a percentage in the middle. So you're going to multiply the percent times the amount. The percent times the amount is going to give you a new percent times a new amount. All right, and that will give you a 15% solution, and this is how much of it that you have, the 75 that you had to start with plus the 150 that you're adding in. All right, good luck. See you soon.